Okay, today we are looking at what's known as flow problems. So in this section, we're now moving on to where there's a direction involved. So when you're going from vertexes, you can go from in one way here to there, not the other way around. And also there would be some sort of capacity on those those roads or edges on the edges, the roads on the edges. So here's down here, what we call directed graphs or a digraph. They show directional information on the edges. So here we go, this particular one there's just 4 vertexes, 4 edges joining up, and the arrows show where you can go. So you can only go in the direction of those particular arrows. You can't go the other way. All right, so that then leads again to flow. So if we're going from one way to the other, we've got a flow happening, and it refers transfer of material. Now that material, that material could be, could be cars, could be water, could be, anything. And so we go from one place to the other. Now, because of these digraphs, these have this one up here, quite clearly we start there, and whichever way we work through it, we end up here. So there's a start and a finish. And so in these particular things, what we call there is the start is the source, and the other end, your finishing end, is your sink. So you've got flow that goes there. Now, however you get there, but you start this end and you flow to that end. So there's your source and there's your sink. All right, and so we've got a flow occurring from one to the other. Now, then what we're going to need to do is we're going to need to work out what the maximum flow is possible. So often the edges are going to have weights on them. So, and in this case here, it says there by the definition, the weights on the edges of the digraph indicate the flow and are called capacities. So, for example, here's 3 diagrams there. So these might be water pipes, for example. So this one can carry 25 litres per minute. This one can carry 58 litres per minute. All right, and there's a few different arrangements. Now, because you can see there's different arrangements and different capacities, our flow is restricted by the lowest capacity. In the sequence, if you like, or pathway. It's probably a better way of putting it. So you can see these, even though these ones here, there, and there, even though they can cope with 58 litres per minute, the issue is these other smaller pipes can only deliver or take away 25 litres per minute. So the flow through each of these 3 arrangements is restricted to 25 litres. Okay, because this one here, and say this one on the left, if it's flowing this way, left to right, while that can get cope with 58 litres per minute, it can only get a maximum of 25. All right, so in this case, these cases, 25 litres per minute. All right, so you can summarise that. You can say for connected pipes, the maximum flow equals the minimum capacity. All right, and so that example up there, the minimum capacity is 25 litres per minute. So that's as much as flow we can get. All right, so here's an example. Let's have a look at an example. And I'll have to keep scrolling backwards and forwards here on this one. So here's a graph, towns A, B, C, D, and E. Edges of the graph represents the roads. So these are one-way roads because you can only go in those directions. And then maximum number of cars. So here, 300 cars per hour can travel that way. All right, so part A says find the maximum flow from A to E. So we're going from A to E through town C. All right, so A to E through town C, the only way we can actually do that is by going around like so. So the maximum flow, when we look, we've got capacities of 300, 600, and 800. It's actually asking what the maximum flow is. Now remember, back up here we said the maximum flow was the minimum capacity. So the minimum capacity here is 300. So, excuse me, the maximum traffic flow would be 300 cars per hour. So all very well that road can cope with 600, but it's only getting 300 in the first place. All right, so 300 there. I'll just erase some of this stuff so that I can go again. So we get rid of those. Should have just crossed them out anyway, not to worry. All right, now let's see if I can be tricky and change my colour of my pen without it changing. There we go, look at that. So then it says find the maximum flow from A to E overall. All right, so when we look at A to E, so there's two ways we could get there. We could get around this way, which we've just worked out to be 300, or we can get this way. So there's two different pathways that we can take. Now this top one here, the maximum flow is the 300, and the bottom one across here, the maximum flow minimum capacity is 150. Now because those two routes are independent of each other, we can actually get 300 cars going that way and 150 going this way. So our maximum flow would be the 300 plus the 150, which would be 450 cars per hour in that situation. All right, so let me erase again these. Right, there we go. All right, let's see if I can be tricky again and change my colour. I'm going to go black here with this because I'm going to add the new road. A new road is being built to allow traffic from town D to C. This road can carry 500 per hour. All right, let me draw a line from D, add this road to C. All right, there it is. There's our line. Oops, there's our line. Oops, I don't know what I'm doing here. So there's our line we've done there. And it says we can go 500 per hour, and it's going from D to C, so it's going in this direction. All right. Find the maximum flow from A to E after this road is drawn. All right. So this is very interesting. So now we're going to think about what are all the different ways we can go around there. All right, so we can still go around this outside bit, around to here, so we can get 300 around that way. We can get 500 to here, and then the fact that they split up there and there is kind of irrelevant, because the maximum we can get to D is 500. So maybe it splits up, maybe it doesn't split up, it doesn't matter. But the maximum we're getting out of there is 300 on that road. The maximum we're getting out A this way is 500 on that road. And then say, for example, well, that 500 did come this way, then, and all the 300 did come this way. 500 plus 300 is 800, which that can cope with anyway, but probably, in reality, it's probably going to split there. So A to B to C, that maximum flow is 300. Oops, let me get my pen back on. So we've got A to B to C. Our maximum is 300. And A to D to C, our maximum is 500. And when we add those together, that's 800. And seeing as I said, C to E, yep, can cope with 800's okay from C to E, so we can therefore carry 800 cars. All right, so I thought I was going to have to scroll backwards and forwards. Anyway, I've managed to be able to squeeze it in there, so I left all this space here to do that on. Don't need that, not to worry. All right, cuts. When I was in primary school, if you get in trouble, you got the cuts. But anyway, that's back in the ancient times when we used abacuses. Times have changed since then. Anyway. All right, so cuts. So in this curve, it divides the network into two parts. All right, so I'm going to go back to some nice orange. And so it divides the network, divides the network in two parts. Other bit, completely separating the source from the sink. All right, so what that means is that for a cut, what it means is if you're traveling from the source to the sink, you've got no option to go through the cut. So this one on the left here shows a cut. So here's our line, which is our cut. So there's no way that we can get from the source to the sink without going through that line. No matter how we go, there is no way we can do it. However, this one over here, we've got a line here. This one's not a cut because I don't have to go through it. I can go around here and get to the sink. I can go around here and get to the sink. So I'm going to add a bit to there, passing through. All right, so it's not a cut because we can still get to the from the source to the sink without passing through. All right, now cuts are quite handy because cuts help us work out the flow. And as it works out, before I get to the so what happens is our minimum cut capacity will equal our maximum flow. All right. So the cut capacity, if you like, is the sum of got a bit ahead of myself here, but anyway, doesn't matter. So look at the cut capacities, sum of the capacities the edge is passing through the cut, only counted if the flow direction is source side to sink side. All right, so here we've got an example. So cut 1, C1. So cut 1, capacity. So here's cut 1. And so it cuts through this line here, which is 15, and this one was 20. So capacity is 15 plus 20 equals 35. If you're looking at the notes on the internet there. So there's more details in the notes. I'm just kind of working through. You'll notice that I made a mistake there. 15 plus 20 is 35, not 30. Just a tip for you. So there's our cut capacity. Now, the next bit, let's see if I can change colours here. Let's right. Change colours in the pen. Let's go that one. Oh, look at that. All right, so this one, cut 2. So cut 2 capacity cuts through this line here. The direction is going from source side to sink side. All right, so source side, sink side. So that's 20 plus. Oh, we've cut through here, but here we're going from D to B. Now D is on the sink side and B is on the source side. So here, this bit here, only counted if the flow direction is source side to sink side. So D to B is going sink side to source side. So we don't count that one, right? We don't count that 6. Then the other line it cuts through is this one here, and this direction goes from B, which is source side, to C, which is sink side. So we've got to add that 14. And so our flow is 34 there. All right, and so the maximum flow from the source to the sink is determined by this cut 2. So we can use our cuts, as I already set up here, got ahead of myself there. We can use our cuts to work out our maximum flow, and I'll just rewrite that again. So our maximum flow is equal to minimum cut capacity. All right, let's have a look at an example. So calculate the maximum flow in the digraph below. All right, I'm going to change back from red to orange. All right, so cuts. Mark in all the possible cuts. Here we've had our possible cuts marked in for us. All right, so we get one there. You could have this one that goes there. You could have another one that goes across there. All right, which is different to C2. It is different because they're going through different edges, okay? And then, of course, you can have this one down the end. And that's all the cuts that there is. So let's have a look at our capacities. So C1 cuts through that line, and that line, and they're all going from source to sink. So we include them all. So we've got 8 across there, 7 across there, 6 are there. And I believe that would be, oops, 8 plus 7. Where did I get the 7? I'm looking at that. All right, let me go here. That's not 7, that's 4. 8 plus 4 plus 6. You'll notice that I've made a mistake in the notes there on that one as well. So that's 17. That's not 17, it's 18, sorry. Whoops. So that's 18. All right, so you'll notice in the notes, I put 7 instead of 8. So I've read that there as a 7, not that 8. All right, so you just got to be a little bit careful. Otherwise, you make mistakes like I have. Cut 2. All right, so we're going through there, there, and there. All going from source side to sink side. This one's 3. This one here is 4. And this one here is 6. So that one is 13. Cut 3. It's this line here, and again, source to sink, source to sink, source to sink. This line is 8. This line in the middle is 4. This line here is 2. And that's 14. And then C4, which is this one around here. And all going from source side to sink side. This one here is 3. This one through the middle is 4. This one here is 2. And so that's 9. So the maximum flow is the minimum cut. So here, in this case, for this one, our maximum flow is equal to 9. All right, so that's it for flow problems and cuts. So in your text exercise 15A, the questions that are on your work plan are the ones you need to look through. So good luck with that. And of course, as always, if you need assistance, make sure you send me an email and I will get back to you.